Okay, so today we're going to be working on solving multi-step equations. Um, if you had math last semester, like I said, this is going to feel very much like a refresher. If it's been a little while since you had math, again, just trying to be like, hey, here's some old things we need to remember. So solving multi-step equations, I break it down into a 5-step process. Is it possible to solve these problems without following this process? Yes. Is it possible to switch the order of some steps sometimes? Yes. However, I like to be systematic about things, so I had this 5-step process here to help, like, hey, if we follow this one step at a time, we should always get to the end. So the first thing I always look to do, now we might not do every step every time, but we're going to see what we need to do. First step I'm always going to look for is to distribute. So yesterday we saw an example where we had, or not yesterday, Tuesday we saw an example where we had to distribute. And then you were like, oh yeah, I remember how to distribute. So first thing we're going to do is look out for distribution. After we distribute, the next thing I want to do is try to combine like terms on the same side of the equation. So if I had two x's on the left side or two x's on the right side, I want to combine them, make it look a little nicer. Once I do that, I want to try and get all variables on the same side. So if I have a variable on the left side and right side, the equal sign, I want to move them all to the left side or all to the right side. Once we do steps 1, 2, and 3, it should look like a 2-step equation. So then we're going to look to undo multiplication and division, followed by undoing addition and subtraction. So we're just trying to take it one step at a time to get something that looks a little easier to do each step along the way. So I'm going to give you some time to copy this down. I know this is a little bit of writing. Then we'll get into our notes. You will see that anytime I have to do my distribution step, you're going to see me writing in purple today. Anytime I have to combine like terms on the same side, that's going to be in orange. Getting all variables to one side will be in blue. Undoing addition and subtraction will be in red, just like we did for 2-step equations. And undoing multiplication and division will be in green. So I'll give you a moment to copy that down. Again, if you're watching the video later, I just want to fast forward through this part until to get to the examples. So some pencils writing, not a big deal, just give me the time to get this down. Then I think I got three, maybe four examples to go over with you. I think it is four. So not every step is going to be necessary every time. There are times we're going to look at it and be like, well, there was no distribution, so I don't have to distribute. There are times you're going to go, oh, my variables are all on the same side already. I don't have to worry about that step. But we're still going to kind of see, like, hey, do I have to do something for that step each time? Let's take a look at our first example. So our first example says 12 is equal to 2 plus 5v plus 2v. So we're going to see what's happening here. So right away, do I have any parentheses for distribution? We're seeing any parentheses here? No. Great. So we get to skip that step. Now I'm going to look. Do I have any like terms on the same side? Yeah, I have the 5v and the 2v. So that's where we're going to go right now. I'm going to say, let's combine those. So 5 plus 2 is? So we get negative 12 is equal to 2 plus 7v. Now, when I look at this, all my variables are on the same side, right? So that's another step I get to skip. This looks like what we were just doing on Tuesday, right? So what am I going to do here first? Subtract the 2. And in doing to 7, now that I know negative 14 is equal to 7, what am I going to do to finish that up? Divide by 7. And here we get that negative 2 is equal to v. I plugged that into the very original equation. Let's see, 5 times negative 2, that's negative 7. Or sorry, not negative 7, negative 10. 2 times negative 2, that's negative 4. So I get 2 minus 10, that's negative 8 minus 4 does take me all the way to negative 12. So I'll give you a moment to make sure you have this copied down. Then again, we will go on to the next example. We are ready. Here with this, what does it look like our first step should be here in 75 is equal to 3x times negative 6 minus 5. Yep. Yep, so we got our distribution happening. 75 is equal to negative 6, or sorry, 3 times negative 6, negative 18, 3 times negative 5, negative 15. Are all my do I have a like terms to combine right now? No like terms to combine, get to skip that step. Are all my variables on one side? Yeah. Now, some of you may say, well, Isaac, did I really have to ask myself that question? Because I already see it looks like a two-step problem. You didn't have to ask yourself that question. I'm just going through it to reinforce those steps. So what am I going to do first to finish solving this up? Yep, add 15 to both sides, because it's a minus 15. And that gives me 90 is equal to negative 18. And now what will I do here? Divide by negative 18. For whatever reason, my brain's saying, division, I'm not remembering that off the top of my head. No worries then. Let's just go to Desmos. So just go to the calculator. 90 divided by negative 18. Oh, that's negative 5. Okay, cool. So negative 5 is equal to n. And again, if we want to check that, negative 5 times negative 6 would be a positive 30. 30 minus 5 is 25. 25 times 3 is indeed 75. So when we're doing our classwork, please make sure you're showing your work. Definitely, I want you to get in the habit on easier problems, showing your work. This way, when we get to our longer problems, which we're about to start getting into, you're going to go, okay, because I was showing my work on the easy stuff, it becomes easy to show the work on the harder stuff, so you at least don't get as confused and overwhelmed and end up not doing it as well. So over here on this one, again, do I have something to distribute first? Yeah, I had the negative 3. So let's go ahead and take care of that. So negative 3 times 1, negative 3. Negative 3 times 6, it's negative 18. It's equal to 14 minus r. Now, yes. Yep. Great catch. A little early in the morning, I did drop the R behind the 18. I had said that, but I did not write it. Thank you for catching that. Now, when I look at this, do I have any like terms on the same side to combine? No, I have R's, but they're on different sides, right? So let's take care of that now. So when I have variables on different sides, I need to get them to the same side. Does anybody remember or have an idea on how to do that? Yeah. So which one are you wanting to add? Okay, you're actually going slightly out of order to how I typically do the steps. If you added negative 3 here, you would be doing nothing wrong. You could still get to the final answer. I'm just trying to follow those steps and getting the variables there. So right now I had the R's on different sides. I see this negative 18R, that's the smaller one. So if I add 18R over, it will let me have more positive variables. And if I have more positive stuff, I feel like there's less chance I make a mistake. So that would be negative 3 is equal to 14. Then negative R plus 18 will be a positive 17R. So now what am I going to do here? Subtract 14. And that gives me negative 17 is equal to 17R. Finish by dividing by 17. And we get negative 1 is equal to R. Now, over on the side in black, you do not have to copy this down. I'm not even having it part of our final notes. But I was given the suggestion right here to add 3 to both sides. I'm going to show you we can do that. We can follow the same logic and still get the correct answer, even though we did steps out of order. So here, if I had -3, this, if we followed that suggestion of adding 3 to both sides, I'd have -18r is equal to 17 minus r. 18r. I go, okay, I have to get all my r's to one side. It looks easiest to get my r's over here, so I could add an r to both sides, giving me -17r equals 17. Divide both sides by -17. And we still get r equals -1. So from a mathematical standpoint, when you made that suggestion of adding 3 to both sides, absolutely nothing wrong. You'd still get to the right answer. But I'm trying to be focused on being systematic and consistent with what I'm doing. So I didn't want to take the steps out of order, though we clearly saw, yes, you can take the steps out of order and still get to the right answer. It's not that big of a deal. I just know if we keep the steps in a consistent order, usually it's better for you guys remembering that. I think with adding that in, that gave people enough time to get this down. So let's go ahead and look at the next example. The net, oh wait, I think I actually did 5 examples here. Do I have one more after this? Yep. The next 2 examples are really, really big. We just have to focus on them. This problem looks super intimidating to begin with, right? Like there's some people are shaking their head no. I know some of us have our confidence in the math like that. But I know a lot of other people will say, there's a lot happening here, right? So that can look intimidating to you, and that's okay. That's why we take it one step at a time. Right away, I see distribution here, right? So let's go ahead and do that. So that's going to give me 2 times 5. So I'm going to do it this way. 2 times 5 is 10k. 2 times 7 is 6, -12. Then everything else is just going to drop down as well. Yes, minus 39 at the end. Okay. Now, do you guys see any like terms on the same side? Yeah, we have the -4k and the 10k here, right? So -4 plus 10 is going to give me 6k minus 12 is equal to -3k minus 39. I want to take a very brief pause here. This problem right here looks a lot nicer than the original, right? Like that looks a lot less intimidating, a lot less cumbersome. So just through getting through steps 1 and 2, we turned it to something big, to something that seems more manageable. Now, do I have variables on different sides here? Yeah, I had the 6k and the -3k. So any ideas how we want to get our variables on one side? Yeah. Doesn't matter which one you do. We can add 3k, we can subtract 6k. Both will get us the same results. Subtracting 6k is just maybe going to make us deal with a few more negative signs. So only issue there is sometimes when we deal with negatives, I know some students can make some minor mistakes there. just gonna go with the first one that was said, adding 3K to help keep us a little more positive. So that's gonna be 9K minus 12 is equal to negative 39. Now this is just a two-step problem, right? What am I gonna do first? Add 12. And that gives me 9K is equal to negative 27. Final step here. Divide by 9. And we get K is equal to negative 3. Whew. I know this problem's a lot. However, when we take it step by step, you have the skills to handle each step, right? It's a matter of just being systematic about it. Yeah, I get they can look like a lot to start, but if we're just systematic, hey, one step at a time, it just gets progressively easier and progressively more familiar. So I know some of you may look at it and be like, there's no way I can figure that out quickly. It's okay that it's not quick. What I care about is we can figure it out. I think we are ready for one final example. This next example is a really big one because I have two sets of distribution. I have more like terms to combine, all that stuff. So we're just going to, again, take it one piece at a time. So I have two places where I see parentheses. The first distribution is pretty straightforward here. That's this 10. So that will be 10x plus 30. Now the next distribution, I know everybody in here can handle it, but sometimes we just forget what to do here. Since it's a negative in front, I still need to distribute the negative. So it's like multiplying everything in here by -1. So -1 times -9 turns into a positive 9x. -1 times -4 turns into a +4 is equal to x minus 5 plus 3. Now, some people may have seen like terms there and said, hey, I can combine them right there. If you would wish to combine like terms right there, I would not mark anything wrong. I just like taking it one step at a time so there's no confusion about what's going on. So let's go on. I have like terms on both sides here. What are my like terms on the left side? 10x and 9x are like terms. Any others? 30 and 4, yeah. The x is on the other side, so I'm not going to, while it is a like term, because it's not on the same side, I'm not going to worry about it right now. So the whole numbers are also like terms. So that would make the -5 and 3 like terms over here, right? So I want to combine those as well. So we see a lot of like terms being combined here, right? 10 plus 9, that's going to be 19x. 30 plus 4, that's going to be plus 34, is equal to x minus 2. Wow, a lot happening here, right? Let's work on getting our variables on one side. So how do we want to get my x's on the same side? So are we subtracting 19x or are we subtracting x? Okay, I'm going to go with what you're saying. It does not matter. If you said I want to subtract 19x, you're still going to get the right result. So I'm going to subtract x from both sides, giving me 18x plus 34 is equal to -2. Now, what am I going to do now that this looks a lot easier now? Subtract 34. And we get 18x is equal to -36. Finish it up. What do we do? Divide by 18. All this, and we just get an easy looking answer like x equals -2. So yeah, that was a lot of work there, right? We had to distribute twice. We had tons of like terms to combine. Then we need to get our variables on the same side. At some points, looking at the earlier parts, some of you might have said like, oh, I don't know that this is going to work out nice for me. It ended up doing so, as should all the problems on today's worksheet. So all the problems we have hopefully do work out nice for you. If you're getting something that's seeming like you're getting a decimal answer, maybe call myself or Mr. Vaughn over and see what's up. You just might be something small mistake you made. But this is why we show our work. If I had made a mistake in this step, and let's say I accidentally added x to both sides, then I start doing all this other work right. My only mistake was it says, say, minus x, I said plus x to cancel it out. You're going to get an answer that looks kind of off to what we got. However, if I'm looking at this as a person checking your work, I could go, oh, bam, found your mistake. And if it's on a quiz, if I can find your mistake that easy, I'm not going to be taking off a ton of points if it's like, hey, everything that followed the mistake was correct mathematics. So that's why showing our work is so important. It helps us see our thinking and logic. So that is our notes. Stop recording.